Hello everyone, welcome back to my YouTube channel. Today we will be solving LeetCode problem 1829. Okay, in this particular problem we have been given a sorted array and an integer called maximum bit. Okay, and we have supposed to form n queries. Okay, so the first query would be we have to do the XOR of all the elements. Along with that we have to also XOR it with an integer called k. Right, what this entire XOR operator should be maximized. K should be chosen in such a way that the entire XOR operator is maximized, right? Whatever K we have chosen, that would be the first element in the XOR in the answer array. Okay, the next element in the answer array, for the next element in the answer array, we will be basically removing the last element which we have previously used, right, which is nums of length minus 1, right, and we have to basically identify a k for which this entire XOR operator is maximized. Okay, so we have to basically every time we have to remove the last element in the previously XOR from the previous XOR operation, and we have to identify a k. Okay, now let me note it down over here. We have been given a nums array, okay, which is of size n, and we are also given another number called maximum bit. Okay, now we have to form an array called answer array, where ith element of the answer array is populated with a k in such a way that k has to be chosen in such a way that nums of 0 XOR nums of 1 XOR so on up to the nums of I XOR k is maximized. Okay, how can we choose a number k in such a way that the XOR from the 0th index till the ith index and its XOR with the number k can be maximized? Okay, what should be this k, right? And if you go back to the question constraints, each number is all the numbers in the given array nums cannot exceed 2 to the power of maximum gate. Okay, that's a very important constraint. Okay, let's say we have three bits. Okay, we have 3 bits available. Maximum number which can be formed using these 3 bits is basically 2 to the power of 3 minus 1. Okay, and the least number is basically 0. Okay, right, which is basically 0 0 0. When we have all the 3 bits unset, we will get the minimum value. To get the maximum value, we will basically set all the elements, which is basically 2 to the power of 3 minus 1, which is basically 7. Right, this is very important property to be noted. Okay, now whenever we are doing XOR of two numbers of same size, same number of bits, okay, let's say we are doing XOR of this particular number with this particular number, right, we would basically get another number of the same number of digits. It can't be more than, it can be less than this, but it can't be more than this, right? We cannot have another bit entering into the picture. That is not at all possible, right? So the maximum number which can be formed is basically when all the bits were set, that is the maximum number which can form, right? So let's say if you have 3 bits over here, the maximum number which can be obtained by doing XOR of any two numbers of 3 size bit is basically 2 to the power of 3 minus 1, right? This is the maximum number which we can get. In our use case, the maximum number which can be formed by doing this entire XOR operation is basically 2 to the power of maximum bit minus 1. This entire XOR operation can't be more than this particular value. Okay, and let me also tell you one more interesting property. Okay, when we do a XOR, when let's say A XOR B is basically C, and if you do A XOR C, we would basically get a B. Let's take an example and try to understand this particular relationship. Okay, let's say A is equal to 2 and B is equal to 3. So the binary representation of 2 is basically 190, the binary representation of 3 is basically 1 and 1, right? If you do XOR, would basically 1 XOR 1 is 0, 0 XOR 1 is basically 1. This is basically, if you convert into numeric, it is basically 1, which is C, right? So as I mentioned, the XOR of A and 1 should be equal to B, which is 3, right? So let's do it. Binary representation of 2 is 1 0, and the binary representation of 0 is 0 1, right? To XOR of this is basically we get 1 1, which is basically 3, which is actually equal to B, right? This property actually is holding good, right? So in this entire equation, we only have a variable which is k, right? We can, all these numbers we already know, nums of 0, nums of 1, nums of I, right? Till all these numbers are predefined, right? So if you compute the XOR of this entire thing, right? Let's say we have computed this entire XOR operator, right? Let's say we have got it as A, right? And we also know what is this, what is the maximum value, right? Let's call it as C, right? We know A and C. Now we have to identify B, which is equal to K. So what K would be in this case, K is equal to A XOR C, right? This is what we have to do. So the every element, the ith element of answer is basically formed by doing XOR from 0th till I element, XOR of all these operators, along with we have to XOR it with 2 to the power of maximum bit minus 1. So if you can compute this entire XOR operator, this entire thing, that is basically the answer for the ith element, right? So if you keenly observe, for every, let's write it down for I minus 1, okay? So answer of I is basically nums of 0 XOR nums of 1 XOR so on up to nums of I XOR 2 to the power of max bit minus 1, right? And in the similar way, nums of I minus 1 would be nums of 0 XOR nums of 1 XOR so on up to nums of I minus 1, okay? So here we basically have nums of I minus 1, right? So if you see this XOR operator and this XOR operator is exactly the same. All we have in this answer, we have additionally nums of I minus 1, right? If somehow, if we can eliminate this particular nums of I minus 1 in this pre-computed result, right? In this entire pre-computed result, if we can exclude the nums of I minus 1, we would basically get the same operator, same answer which we are looking for, right? So once we have this entire value, what we will do is basically again do it with this particular number, which is 2 to the power of maximum bit, right? So let me also explain you one more example, one more how can we eliminate this, right? We have a basically property, if you XOR with the same number, if you do XOR with itself, you will basically get a 0. And if you have a number whose, if you do XOR with 0, you would basically get the same number, right? So this entire thing, I would call it as A, right? This is A XOR, let me call it as B, okay? Let me call it as B and let me call it as B, right? We have B XOR A over here, right? Our intention is to get B, right? How can I get it? B XOR A, if you do XOR with again A, you would actually get a B, right? This operator will turn out to be 0, and B XOR 0 is actually B, right? That is what we want over here. So all we have to do, first compute the XOR for all the elements from 0 to n minus 1, and as we propagate, as we go from index 0 to n minus 1, every time we gonna let's say we have got this XOR from 0 to n minus 1. Let's call it as max XOR so far. Okay, so for the first element we're gonna do XOR of all the elements and XOR with this particular number, right? For the next element, what we're gonna do, we're gonna simply XOR with the last element, and whatever the computer result we have, we're gonna XOR it with 2 to the power of maximum bit minus 1. So this would be more clear once we jump into the coding exam. Once we do coding, right? Let's jump into the coding. Okay, let's. Yeah, so we have as we stated that we will be given nums and the maximum bit, right? First task is to get the XOR of all the existing elements, right? So let's say XOR, let's define a variable called XOR so far is equal to 2, and we have to basically iterate from the existing elements and get the XOR so far, right? So this would basically give us XOR till XOR of all the elements, right? Now the next task is to form the answer array, right? So answer array will have a length equivalent to the nums array, right? So we will basically define the answer array. Now that we have to iterate for n times, right? Iterate for the number of elements in the array, and we have to basically populate the answer of I. Answer of I is basically the XOR of all the elements, and we have to XOR it with the 2 to the power of maximum bit minus 1, right? So how can I, let's call it as a mask. Okay, so one right shifted by maximum bit would basically give us 2 to the power of maximum bit, and we want to subtract 1 from it, right? Now we have to basically XOR with the this particular variable, which is XOR so far, right? So for the next subsequent elements to populate, right, we does not want the last element to be included. Every time we're gonna populate the next query, we want to remove the last element which was previously included in the XOR, right? So for that, what I would do is basically XOR it, right? XOR the last element which was included so far. So let's return it. We have some okay, we have basically subtracted I twice. We are not supposed to do it, right? We just want the last element to be removed for every iteration. Right now that the test cases got passed, let's submit this, and yeah, it has passed all the test cases. Thank you. Subscribe for more such videos.